Again, the questions can be like specific problems from the homeworks, or they could be general, like conceptual. We're just kind of opening things up for questions. Mackenzie?
Okay, so
So worksheet 2, number 6. Okay. Sure, we can talk about that. So what I would do first on a problem like this is I'm just going to sketch a little picture of kind of what's going on. So I have like negative 210 is up here. That's a maximum, it says. And then 14, negative 18 is down here. That's the minimum, it says. So if I draw a full period, it's going to look like that then, right? Or I draw the other half of it with a dashed line. Does that feel okay?
Yeah.
Okay, so what I want to ask myself is how much of a period is the part that I'm given? That looks like a half to me as well. You agree? Okay, so I can say like 1/2 of a period is going to equal the horizontal distance from negative 2 to positive 14. So 16 units, right? Is that okay?
That's where I get lost.
Okay. So if we just draw like a number line, we have negative 2 and we have 14. How many units are in between them? So you could like count negative 1, 0, and there's 16 of those, right? Does that feel okay? Like 2 units to get back to 0 and then 14 units to get to 14. Again, you can think about it on a number line. You can think about it common sense wise. You can just subtract the 2 numbers and put an absolute value around it. You can take the bigger number and subtract the smaller number. All of these are doing the same thing, because all we're talking about is a horizontal distance between 2 points. So any way you want to kind of do that, whether it's visually or like with arithmetic, I think I did, in the notes, I think I wrote like XR minus XL, the X coordinate from the point on the right minus the X coordinate from the point on the left. But it's all doing the same thing, right? It's not like there's only one way to do that. Get that out of there. And then we know that a period is 2 pi times c, or absolute value c, I guess I should say. So 1/2 times 2 is just 1. So I'm left with just 1 pi equals, or 1 pi c equals 16. And I'll divide both sides by pi. And I know that the c's I always choose to be positive. So I'll just say that c is going to equal 16 over pi. Does that feel okay?
Yeah.
It's okay. Ava?
How did you get that one?
So if I look at the picture that I've drawn is one full period, right?
Right.
The piece that I've highlighted is the piece that I know. How much of a period does it look like that piece that I've highlighted is?
Half. But
That's it.
isn't like it usually 2 pi? Like isn't the period usually 2 pi?
So yeah, so I've gone and replaced period with 2 pi times the absolute value of c. After I figured out that 1/2 a period is 16, or you could say that 1 period is 32. You could start there. That's okay to do also.
Okay. Thank you.
That's still doing the same thing, right? It'd be if you started by multiplying both sides by 2, and then you make the substitution. That's fine to do as well. Does that feel okay?
Yeah, thank you.
Sure. Was it Evan? Did you have your hand up also?
You do 8.
Sure. So that's worksheet 3, you say?
No, worksheet 2.
Oh, okay. So similar kind of question. So I'm going to start by drawing a picture because, again, I'm given just 2 points, and I think a picture is often quite helpful. So let's see. 215 is probably there, and then like 8, -5 would be over there. So it tells us that 215 is a midpoint, and this is the next extrema, so that has to be a minimum then, right? And if I'm going to complete the rest of my period, so I'm going to have it go up and then come back down. You good with that? Okay. So I like to start by finding the K. So the K is just going to be this distance, or I'm sorry, the K is free, right? Because I know the K has to go through the midline point. So since the horizontal line going through that has to match the y coordinate of that midline point, I just know immediately that K is 15. Does that feel okay?
Yeah.
Everybody else okay with that? Next, we'll find the amplitude. So that's just the distance from an extreme to that midline point. So basically, we're just looking at the distance from -5 to 15, which is 20, right?
Yeah, but then I get everything else you're about to do, and then when I wrote the problem, I just didn't get every single time you wrote the 20, and the single one, it was negative.
Okay, we'll talk about that in a second. Next, we have to find the period, or find the C value. To do that, we're going to look at the period. So if I look at the highlighted section, how much of a period does that appear to be?
Is it 1/4?
Yeah, it looks like a fourth. You guys all buy that? So I'll say that 1/4 of the period. Again, and that's going to just be the distance between the x coordinates. So going from 2 to 8 was 6 units. So you could say that like 1 period, or 2 pi c, is equal to 24 by multiplying the 4 over if you wanted to go that route. And then we'll divide both sides by 2 pi. And again, my c I always pick to be positive. So we have c is 12 over pi. And the last thing that I'm going to do is I'm going to choose to either write a sine or cosine function, find the value of h, and decide whether the a needs to be positive or negative. So far, so good? So in this problem, it's equally easy to decide to use a sine function or a cosine function because you have both a midpoint, which is something I'd want for it to use a sine function with, and we have an extreme point, which is something I'd want to do a cosine function with. So it doesn't really matter which one you choose. Evan, did you have a preference on which one we use?
I use
So you want to use cosine? Great. So we'll choose cosine to be our function. From cosine, the parent function point I'm going to choose is the one where the x coordinate is 0. That's the maximum. In general, I'm going to pick the trig function. I'm going to pick sine or cosine so that I'm able to use that point whose x coordinate is 0. From the transform function, since 0, 1 is a maximum, I need to pick another extreme point to go with it. So I need to use 8, -5, which from our picture we can tell is a minimum, right? Everybody's okay there? Okay. So we've decided this is cosine because we're going from max to min. That tells us that the A is negative.
Wait, so why'd you put 8, 5 again?
That's the extreme point we were given in the problem.
Okay, so for cosine function, transform will always be the extreme.
So no, it doesn't have to be, but it's easiest to do it that way.
Okay.
That's the time saving. That's the way that I would recommend doing it.
If you're given 2 extreme points,
It doesn't matter.
Okay.
You'll get a different answer
The
for,
extreme point is easier
but
for
they're,
cosine, obviously.
yes.
Okay, so
Yep.
like I did.
So I'm not quite done with this, so I don't want to get too deep into like what if.
Okay.
Okay, Evan. So we've picked cosine, we found the value or the sign for A. We still need to find H.
Wait, but okay, so say the transform function was maximum and it was cosine, would you just make the parent function minimal?
No, the parent function is this part is always the same.
It's always gonna be max?
Yeah, 0, 1 is a maximum
Okay, so
in the
then
parent
it's going
function.
to- So it's going to a max, so it's max to max.
Then the A would be positive if that was what happened.
Wait, why don't we already know A?
We know the absolute value of A.
But isn't that just, isn't the absolute value of A just like positive?
Correct. But we need to find the value of A, which if something's absolute value is 20, we could have taken the absolute value of 20, or we could have taken the absolute value of negative 20. Right? So that's what we need to determine here is whether our A value that we're using should be positive or negative.
And you figured that out from, like you knew that A was 69 and 20.
So when I compared the extreme point of 0, 1 from my parent function with the extreme point of 8, negative 5, my parent function point was a maximum and my transform function point was a minimum.
Oh,
Because you've gone from max to min,
yeah.
the sign of A needed to have changed. And Evan, are you good with why the H is 8?
Oh, yeah, no, I know that.
Okay.
I was just curious about that.
Yep. So when we put it all together, this is one possible answer. Again, there's infinitely many of these, so like you could have done lots of different things to get different answers. The thing that'll be the same every time will be the C, the magnitude of A, and the K in a problem like this would have all been the same. But if you found a different answer, maybe the sign of A is different or the value of H is different, or even the sign of C, if you wanted to go that route, could it be different? I would recommend against messing around with the sign of C, but you could do it that way also. Paul?
So if I did a sine function, would the H be 2?
Yes. Yeah, and the A would still be negative in this case.
Right. And when we got A, it was just the distance, it was the y distance, right?
Yeah, it's a vertical distance. Yep. Mackenzie.
Can you do number 6 on the problem?
Sure. Okay, it says to find the amplitude, period, frequency, and then graph. So the first thing I would do is pull the values from of A, C, H, and K just from looking at my equation. So the A is -3/2, the C is 1/2, the H is 0, and the K is 0. Mackenzie, you okay with that?
Yeah.
Everybody okay with how I pulled those numbers? Okay. The amplitude is just the absolute value of A. So that's going to just be 3/2. The period is 2 pi times the absolute value of C. So that's going to be pi. And the frequency is the reciprocal of the period, so 1/pi. Max, I have some papers for you here. Evan?
Can you go back to worksheet 2 and just explain how you find this period of number 9?
We're not finished with this problem yet, but when we do finish, we could go back and do that. Do our max. Okay, Mackenzie, still happy there? Okay. Next thing I need to do is we need to graph this thing, it says. So I'm going to start by making my transformation map. So I know that transformation map is Cx plus H, and then Ay plus K. So in this case, my C is 1/2, my H is 0. I'm not going to bother to write the plus 0. My A is -3/2, and my K is 0. I'm not going to bother to write the 0. And now I'm going to use that transformation map on the key points for cosine. So if you went back and you look at lesson for 3.1, the very first one, we have our key points from cosine. These are not things I'd expect you to memorize. I have them memorized because I've been doing this for a long time. But that's where I'm pulling these numbers from. And now all I'm going to do is I'm going to take the x's and plug them into the x in our formula, and take the y and plug them into the y in our formula. And I'm just going to do that for each of the points. That's correct. Come on. Oh, that should be 2 pi 1. My mistake. I thought you were asking me because you couldn't read it, not because you didn't think it was right, because it wasn't right. Okay, so there's my key points. What I need to do now is to plot these key points and then extend my graph so that it covers a range of values from -4 pi to +4 pi, I think is what the directions asked for. All right, so that looks okay. So I'm going to go, I guess my tick marks, I'm going to make 1/2 pi, so that means that I need 8 tick marks on each side. Rather than, I could go by 1/4, but I just don't think I have the artistic skills to sneak 16 tick marks in here. You know what I mean? 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 1, 2. Okay, so I have 0 and -3/2, pi/4 and 0, pi/2 and 3/2, 3/4 pi 0, pi and -3/2, So it's going to do that much. And then I'm just going to extend this by continuing to follow the pattern. So midline, maximum, midline, minimum, midline, maximum, midline, minimum, midline, maximum, midline, minimum. So filling this in. And then doing the same thing over here on the other side. So midline, maximum, midline, minimum, midline, maximum, midline, minimum, midline, maximum, midline, minimum, midline, maximum, midline, minimum. And there we go. Mackenzie, are you happy with what we did there? You're welcome. Any follow-ups on this one before I move on to Evan's question? Okay. Evan, what's up?
I'm confused about the period for number 9 on worksheet 2.
Okay. Oh, we already have this one. Over here, I think. Okay. So again, I'm going to start just by sketching a picture. So I have 10, negative 20, and then 46, 18. And we're told that that's a minimum, and that is the second maximum after it. So I'm going to have a maximum, and then another minimum, and then up to there.
I do think I understand now.
Yeah, so if we look at this,
That's the minimum number, the maximum. So you need to reduce it.
so that's one period right there. Everybody agree? And then this looks like about another half. So it appears to be 1.5 periods is going to equal the horizontal distance between 10 and 46. So 1.5 times 2 pi absolute value c. So 1.5 times 2 is 3. If I divide both sides by 3 pi, I get 12 over pi. And we always choose the c to be positive. So that's all. Does that feel okay?
Yeah.
So again, getting the picture at the beginning to see what it is that you're doing, I think is often quite helpful, especially for the period part, right? Where it's like, okay, I don't have a full cycle. Like, how much of a cycle do I have? You know? Paul?
Worksheet 2, could you do number 7?
Yeah, sure. So again, drawing the picture. So 3, 0 is my minimum. 23, 20 is my maximum. Okay. So my midline is going to be like halfway in between these. So that should be 10. Good.
And just find that by adding the last and then divide by 2.
Yeah, you could do it that way, sure. If you have the maxes and mins anyways.
Okay.
If you have the midline points, just the midline.
Yeah, so it's literally the average if you have the max and the min. So it's like the average y in between. And then the A is going to be that distance,
Okay. So
which is
half the midline.
just 10, right? You're going from 10 to 20.
Oh, okay. So it's just okay.
Is that okay? Or half the total distance between the two of them, which, again, since one of the y coordinates is 0, that total distance is going to be the same as the midline, right?
It was a different one.
Yes, yeah. In most cases, they would be different. And then if I look at the piece that I have, how much of a period is that?
That's 1/2.
Okay, agreed. So 1/2 the period is going to be the difference in the x coordinates. So 20 is the total change there. So I get then that when I solve that, 1/2 of 2 pi c equals 20. So c is going to be 20 over pi. Is that okay? And then the last thing we need to do is decide whether we want to use sine or cosine.
We want to use cosine.
Okay, let's use cosine. I agree there. So from cosine, the parent function, we're going to use the point 0, 1, which is a maximum. And which point do you want to use from the transform function?
3, 0.
Okay, 3, 0, which we're told is a minimum. So the sign for A needs to be?
Minus.
Good, because we have one of them's a max and the other's a min. And the value for H needs to be?
3.
That's correct. Since the x-coordinate is 0, on the parent function, the x-coordinate from the transform function will be our H. So then we just put it all together.
And we switch it because it's like 1 over c.
Right. Yeah, that's why I'm writing the reciprocal, exactly. This piece is 1 over c.
Okay.
Yep. Alex.
Did you do number 7 on the chapter 2 problems?
Sure. Let's see. I think I have that already. Okay. So it says identify the function rule based on the graph. So we're looking for a sinusoid, right? An equation. So let's find the midpoint or the midline first. Should be easy to see that. What's the midline? Right there, right? So that tells me that since the midline is the same as k, that k is 0. Then let's find the amplitude. So that's like the distance from an extreme to the midline. So that distance is 1. Do you agree with that? Next, we're going to find the c by looking at the period. So I notice that what I have drawn here is just one cycle. So that cycle starts at -2 pi and ends at +2 pi. So that would be 4 pi total. So the c in this case is going to be 2. Still doing good? Okay. The last thing that we're going to do is we're going to decide whether you want to do sine or cosine, and then the sign of A and the value for H. So which one would you like to do? It doesn't really matter since we have the graph. It's not really much hard to do one versus the other. Okay. So from the parent function on sine, we're going to do 0, 0 as our midline point. And the type of midline point here, it goes minimum, midline point, and then maximum. From our transform function, we need to also select a midline point. I would pick 0, 0 here, although it's not the only option, but I think it's the obvious one. And if I look at this midline point, we have a maximum, and then we have the midline, and then we have a minimum. You see that? Okay. So if I compare these, I know that the A value has to be positive or negative. Negative, because they're the opposite order. And then the H value has to be, yeah, since the parent function x is 0, the transformed function x is going to be my H. And there's everything I need. So I didn't bother to write the zeros.
Yeah.
Does that feel okay? Of course. Joe, I saw your hand up.
Yeah. Why is the period equal to 4 pi? Is it just is one period just
one non-repeating cycle.
Okay.
So this one started at negative 2 pi and it ended at positive 2 pi. So that's 4 pi total distance covered. Does that make sense?
Yeah.
Okay. Mackenzie? Sure. So it says to identify any vertical asymptotes on the interval 0 to 4 pi for 3 tangent x over 2. Oh my goodness. So I remember that when I look at the key points for sine, So I remember for tangent, 2 important facts. One is that the period is pi times c. And the second is that I have my first asymptote, or an asymptote occurs at positive pi over 2. I identified that one because I also have one at negative pi over 2, but it's negative pi over 2 is not on that interval from 0 to 4 pi, so I didn't care about it. So the reason I know that is from, how did we do that? So the graph of tangent, I know the period here. Hi, Miss Garcia.
I think Joe was over for a second.
No problem. And then I have a key point with an asymptote at pi over 2. So again, these are just like nothing that I really had to figure out. I just kind of looked it up off of what I knew about tangent from my tangent notes. Is that okay so far? Okay. Peyton, you're good? Okay. So what this is telling us is normally, if we are first asymptotes at pi over 2, the next asymptote is going to be 1 period later, right? Because you're going to get an asymptote at the beginning and end of every period. And since if I look at my original function that I've given, there's no horizontal translation, right? There's no h value going on. So it's just going to be like my start is still going to be at pi over 2, and then 1 period later I'm going to get another asymptote, and 1 period after that I'll get another, and another, and another, and another, until I get to the end of 4 pi or whatever the interval was. Yeah, except the period here in this case, since my C value is 2, is going to be 2 pi. So I have an asymptote at pi over 2. And then I have another asymptote at pi over 2 plus 2 pi, which is 5 pi over 2. And then my next one would be at 5 pi over 2 plus 2 pi, which would be at 9 pi over 2, which is too far, right? That's 4.5 pi. Does that make sense? So my only asymptotes are going to be here and here. Since the problem asks for the asymptotes between 0 and 4 pi. Does that feel okay?
Yeah.
Peyton.
Could you do 13 on worksheet 1?
Sure. Any follow-ups on this one before we move? Okay. Worksheet 1. Number 13. Oh, it's right there. Okay. So the first thing I'm going to do is I'm going to identify the values for A, C, H, and K because I need those to figure out the asymptote, midline, period, frequency, and to make my transformation map. Before I can find those values of A, C, H, and K, though, I have to make sure that my equation is in the correct form. Namely, the big thing I'm looking for is to make sure the leading coefficient on the x is 1, which is not what we have right now. So I'm going to begin by doing a little bit of factoring so that the leading coefficient on x is 1. So I'm going to factor off a 2. So when we're factoring a number, a constant off like that, we divide to find out what else is left. So 2x divided by 2 is just x. And then pi over 2 divided by 2 is the same thing as pi over 2 times 1 over 2. Right? Dividing by a number is same as multiplying by its reciprocal. So that's how I'm going to get pi over 4. And then I'll write the plus 0 at the end. And now I have my values for A, C, H, and K. Okay? And the factoring piece is critical to getting the correct H value, right? Okay, so the amplitude is the absolute value of A. That'll just be 3. The midline is y equals k. That's y equals 0. The period is 2 pi times the absolute value of c. So that's just pi. And the frequency is the reciprocal of the period, so 1 over pi. Peyton, are you okay with that?
Yeah.
Okay. Again, all these little formulas or whatever were in this table here that we built, right?
It was mostly just a factor.
Yeah, that can definitely trip you up. Now that I have that, I'm going to write my transformation map. So I have Cx plus H, Ay plus K, and the K is 0, so I'm not even going to write that. And then I'm going to copy in my key points for sine. These are things that I would give you on a test or a quiz, so you don't have to memorize that kind of thing. And then I'm just going to plug in my x's into my x spot and my y's into my y spot and evaluate. That's pi over 4, 0. And then it's going to be pi over 2, negative 3. And 3 pi over 4, 0. And then pi, positive 3. And then 5 pi over 4, 0. Again, I'm just doing that arithmetic in my head, so I'm like adding fractions and doing all that nonsense. Are you cool with with that, Peyton, or do we need to go slowly through something like that?
No, I'm good with that.
Okay. You'd be surprised. Sometimes fractions cause all kinds of nightmares for people. Okay. So I'm going to plot these 5 points on my grid. So I notice that every grid line is a half a pi. So a quarter pi is in between 0 and a half. And then half and -3, 3/4 and 0, pi and 3, and then 5 pi and 0. So this is my 1 period. And then I'm just going to kind of extend this by continuing the pattern. So down to a minimum, back to midline, maximum, midline, minimum, midline, maximum, midline, minimum, midline, maximum. And doing the same thing over here. Feel okay?
Yeah, you got the quarter pi from H, right? Like that's how you know.
Yes. Yeah, so this again, it's Cx plus H, and then Ay plus K is the map.
And then your starting point, where'd you get that? Like, how did you know to start, like, not at 0, 0?
Well, I mean,
Just from that? Like,
so I'm plotting, I plotted these,
oh, right.
right? So we started with the parent function and we transformed those points into points on my new graph.
Uh-huh.
And then I'm going to plot the new points. Is that
Yeah.
okay? Joe.
For 14, why do you have to factor, or why don't you factor out?
Well, because there's no h. Because the h is clearly 0 there, because there's nothing else in the parenthesis with the x. So you don't need to worry about factoring there. Because you could factor it, but the h is still 0, whether you factor it before or after, because you divide 0 by anything non-zero, it's still 0. Is that?
Yeah.
Okay. Paul.
Could you do number 5 on worksheet 2 with the sinusoid?
5 on worksheet 2.
I kind of messed myself up with amplitude.
Okay. So the amplitude is square root 6. I know the absolute value of A is square root 6. If the period is 7 pi, I know that 2 pi c is equal to 7 pi. So c is going to equal 7 over 2. Again, I always choose the c to be positive. Okay. And then you said you want to use sine, which is what I would use. So the parent function is 0, 0. And the order for that midline point is minimum, midline, max. And we're going to send that to the transformed function point 418. And we don't know what kind of midline point that is, so we can pick.
Okay.
We can either make it the same as the parent functions, or you can make it the opposite. It doesn't matter.
Okay.
They'd both be correct. So I'm going to pick it to be the same, which tells me that the A needs to be the positive. And then the H has to be 4. Oh, and the K is 18 also, yeah.
I think that's where I got it mixed up. There was correction on the point, so
Yeah, so,
it's kind of lost.
gotcha. Yeah, so you're free to choose, right? All it has to do is go through the point. It doesn't matter. We don't have anything else to get in the way, so
Okay.
as long as it passes through, we're good.
Okay. I see.
Joe?
What is this, like, min to midline to max? Like, how do you find that?
So if I look at the graph of sine, it looks like this, right? So there's two kinds of midline points in a sine graph. This is one kind of midline point where on the left is a minimum and on the right of it's a maximum. And here is another midline point where the left is a maximum and the right is a minimum. So that is going to determine whether our A is positive or negative. Are we mapping to the same kind of midline point or a different kind of midline point? So in the parent function, this part is always the same. What we had to do is we had to look at our transformed function then and figure out what order or what kind of midline point we had there. In this problem, we're not given any kind of detail about the type of midline point. All we know is that it just has to go through there at a midpoint. So we were free to choose which type we wanted to use, so I just used the same kind as the parent. You could have used the opposite kind and made the A negative, still going to be a correct answer. Is that what you needed? Okay. Peyton?
I feel like you're, like, for the parent function, is it always just like 0, 0, 0, 1?
So I am always going to choose to use sine or cosine so that I'm able to use a parent function point whose x-coordinate is 0. You don't have to do that, but it makes the problems easier if you're just choosing your function carefully so that you're able to do that.
So how do you determine if you're using 0, 0, 0, 1?
Okay. Well, it's going to depend on whether I want to use sine or cosine. And that's going to be determined by the type of point that I have. So if I want to use a midpoint, I'm going to use sine. If I want to use a maximum or minimum, I'm going to use cosine. Is that?
Yeah.
Okay. And sine, the parent function point is 0, 0. And cosine, the parent function point that you use is 0, 1. Joe?
Okay. Where does H come from again?
So as long as I'm picking a parent function point whose x-coordinate is 0, the H is going to be the x-coordinate from the transform function. And likewise the K. If you're picking a parent function whose x or y-coordinate is 0, then the K is the same as the y-coordinate from the transform function. Mackenzie? Yes, on the problem set? Okay. Are we good to move? Peyton, Paul, Joe?
You said, one more time just to clarify. You said sine is when it's midpoint, and cosine is for maximum.
Yes. And the reason that is when you do this pairing like we've done here, you have to pair a midline with another midline point. You can't pair a midline point to a maximum, right? Because think about what you're doing when you do a transformation. You're doing the exact same thing to every point. So you can't have something that was in the middle before and you transform it, now it's the highest point on the graph because you're doing the same thing to all the other points, right? It still has to be in the middle. Does that make sense? And the same thing with like a max or a min. It can't automatically turn into like a midline point because it has to be at either the top or the bottom. Does that make sense? Okay.
So when you're finding the amplitude, it's just the distance from that to the midline point, right? From the max or min to the midline point.
Sure, you can think about it that way.
Or half of the
Total distance
Total
between
distance.
max and min.
Okay, I see.
Or you can just think it goes through the midpoint.
Okay. And the midline, the difference between the midline point is the point is the point where it's in the middle. And it's like total.
So a midline point is a point that lies on the midline.
Okay. And then I see.
Mackenzie, you said 17. All right, let's look at that. Oh, that's the other one? Sure. So here, we know our period is going to be pi times c. The c in this case is a half. So that's pi over 2. Again, there's no horizontal translation to worry about. So our first asymptote is just at pi over 2. And then our second one is going to be pi over 2 later from that. And then pi over 2 after that one. And then pi over 2 after that one. And you can kind of see where this is going, right? You mumbled there and I didn't understand what you said. You said that it was some conflict on the answer key? Oh, sure. Why? Oh, that's why that might have been. Yeah. Oh, boy. Oh, Boise. Okay. So did we goof that one up too then? We sure did. Okay. Let me go back. Yikes, Rooney. Okay. Let's just do this on the side here. So we have the point pi over 2 undefined from the parent function, right? And we're going to transform that because our c here is 2. So that becomes pi undefined, right? I'm doing 18. Sorry. You're good with that though? Okay, so that's, and our period is still 2 pi. So we really have pi for the first one, and then pi plus 2 pi for the second one. And if I do it again, it's too big. So here, same thing. So our first is pi over 4. Well, the c is a half, right? So I'm doing 1/2 times the x. And we're still adding 4 pi after that. Or, I'm sorry, a pi over 2 after that. But what's that? 7 pi over 4. And it just keeps on going. Right, what do we get? 9 pi over 4 after that. And then 11 pi over 4. And then 13 and 15. And that's the last one. Notice the pattern, you're just adding 2 to the numerator each time, right? And 15/4 is like 3.75. If I add a half one more time, I'm going to be over 4, which is not an asymptote we care about. Yeah, my apologies. Thank you for following up on that. I'm glad that you said something when you're like, yo, that doesn't match my answer key. Because again, we've seen mistakes on the answer key before, right? So it's not always that Mr. Kulik has made a mistake doing the problem, although that was the case this time. Alexis.
Can we do number 1 on the chapter 3 problems?
Yeah, sure. Let's see. Do I have those already somewhere? Yeah, I do. Okay. It says to write the amplitude period and describe the transformation. Okay. So first thing I would do is find the values for A, C, H, and K. This one, it's really easy. You can just read them right from the thing, right? So A is 3, C is 1, H is 0, K is 0. So our amplitude is 3, the absolute value of A. And our period is 2 pi, so 2 pi times the absolute value of C. You good with that? Okay. And then the language of transformations, there's only one thing happening because the A is 3. That's the only thing that's changed. Since the A is positive, we don't have a reflection, so I don't have to worry about that. But since the absolute value of A is greater than 1, I do have a vertical stretch. So that's the only thing that I would write. If I was writing it like, numbering it like 1 through 6 or whatever. Oops. So the C's I do first. The reflections come before the stretches. And then the translation left to right and then up and down. So that's like probably the way that I would have formatted it, my answer, but as long as you just indicate the only thing going on is a vertical stretch, I did okay.
How'd you get the period?
2 pi times the absolute value C.
Oh, okay.
So again, like I'm just referring back to these formulas from the 10-1 notes,
Okay.
right? Yeah, what's up, Mackenzie?
If C is 1 pi, then when we put it back into the equation, would you get 2 or would you get 1 over 1? Or does it?
Those are the same thing. So either way of writing it is okay. Oh. Okay. You guys all knew this was coming, right?
Yeah.
I put it in the notes for the video, and then I'm sure by the time. But you first hour takes that everybody knows, and then a day that it's surely within 24 hours. So there are just 2 questions. The first question I put is a graphing question. I put a bunch of blanks for you to record information in. If your writing is kind of too big for the blank, don't feel like you have to try to like cram it into the blank. I write small and I have a bad habit of underestimating the space that people need to write their numbers and stuff. Just write it off to the side or whatever, as long as things are relatively clear. There's no issues. You don't feel like you have to use the blanks that I provided. Although you can if you'd like. No problem. Yeah.
Did you say we don't have to fill these blanks if we don't need to?
So I want you to record that information, whether you can't, if you can't fit your number in that blank, just write it off to the side or whatever.
Okay.
But I do want you to record that information. It just doesn't necessarily have to be in the space that I provided. Like, yeah, I have terrible penmanship, but I can't put my
Okay, thank you.
Yeah. I have little tiny chicken scratch writing, so I'm a bad judge of like how much space somebody needs.
Yeah.
Some of us have big bubbly handwriting, and it's like I can't fit my person there. Okay, don't worry about it. Just write off to the side. That's fine.